go ahead and start with this one first. All right, let me go ahead and scoot on back down here. All right, so we're going to start with this one first. Now, grab your pen and paper so we can go ahead and get started on this. So those of you guys that are in here for General Chem 2, welcome, welcome, welcome. Let's get into our first problem for the night. It says a clandestine lab was operating at a high temperature to synthesize a banned stimulant. If the reaction has delta G, the standard, that's what that little zero right there means. That means standard. If the standard delta G is negative 5.0 kilojoules per mole and delta G, okay, is positive 2.0 kilojoules per mole, when Q equals 10.0, what temperature was the lab operating? Now, in this case right here, because they gave you 2 G's, okay, and you're looking for your temperature, you would have to remix the formula in order to solve for that, right? Negative, and here are the numbers right here again, y'all. Negative 5.0 kilojoules per mole minus 2.0 kilojoules per mole. So let's write those numbers out right there. Negative 5.0 kilojoules per mole minus, even though that says positive, but remember there's a minus sign, 2.0 kilojoules per mole divided by negative 8.314 joules per mole dot Kelvin times the natural log of Q, which was 10.0. Okay? Yeah, well, I'm going to do that part. Yes. So because I have kilojoules up here, right? Once I get this number, this answer right here on the very top, I will then convert that to a joule, okay? And for those of you all that don't know, okay, remember, 1 kilojoule is equal to 1,000 joules. So that means I'm going to multiply this top right here by 1,000. So negative 5.0 minus 2.0 is negative 7.0 kilojoules, okay? And then you're going to multiply that times 1,000. So you're going to basically get on the very top negative 7,000 joules per mole divided by, now let's go ahead and do this part right here as well, okay? We're going to get the natural log of 10. And I'm plugging this in now on my calculator, which is 2.30258 times 8.314, which is negative. I get negative 19.14. All right, joules per mole dot Kelvin. Now, remember, your units are going to cancel out. Joules per mole, joules per mole. See? Okay. So now let's plug this into our calculator up here. You all know also that those two negative signs are going to cancel out, right? So you're going to end up with 7,000 divided by 19.14, and you get 365 or 366 Kelvin as your answer, okay? Just like that. All right.